All right, let's use the product to sum formula to help us evaluate cosine of 11 pi over 12 multiplied by cosine of pi over 12. So I went ahead and I picked out the formula that goes product to sum, where it goes cosine of something multiplied by cosine of something. All right, cosine multiplied by cosine, just like we have in our original starting problem. So as we fill in here, I'm going to identify alpha is 11 pi over 12 and beta is pi over 12 as we plug into this formula. So we can rewrite our original expression as 1/2 multiplied by a big set of brackets, cosine of alpha, 11 pi over 12, minus beta, which is pi over 12. To that, we're supposed to add cosine of alpha plus beta. So alpha, again, is 11 pi over 12, plus beta this time is pi over 12. We can do a little bit of reducing down. What's inside of these cosines will reduce down. So we can say, well, that's 1/2 cosine of, instead of 11 pi over 12 minus pi over 12, these will combine together pretty nicely and give us 10 pi over 12, which will reduce further in a second. And then cosine of 11 pi over 12 plus one more pi over 12 makes 12 pi over 12 on the inside of that cosine. Let's see what other reducing down we can do. We can go ahead and say, well, that's cosine of 5 pi over 6 is equivalent to our 10 pi over 12, just reducing down multiples of 2 numerator and denominator. Plus, when we have 12 over 12, that's equivalent to 1. So we can say that's equivalent to 1 pi on the inside of that cosine. Now, to evaluate these, it may be helpful to find a reference angle, at least for the 5 pi over 6. The cosine of pi, that's a quadrantal angle. So we'll deal with that slightly differently. But what I would probably do for the 5 pi over 6 is identify that that's going to be in the second quadrant. Wraps around somewhere into the second quadrant because it's bigger than half a pi, but it's smaller than a whole pi. And then I would identify our reference angle is the angle drawn from that one to the x-axis. We can hopefully pretty easily at this point identify that's going to be another pi over 6. If it goes 5 pi over 6 this far around, we need another pi over 6 to complete the whole pi around the top half. Okay, so I'd like to plug in that reference angle. So coming down here, I'm going to say that's 1/2 multiplied by cosine of, plugging in this reference angle, pi over 6. But here's where, when you plug in a reference angle, you have to be very careful about our original angle was in the second quadrant. So I like using the phrase, all students take calculus, to help me remember, should that be positive or negative in the second quadrant? Well, only sine is going to be positive in the second quadrant. We're dealing with cosine in the second quadrant. So we have to be careful that when we insert that reference angle in, this is the place where you want to include a negative out in front, and be very careful about should it be positive or negative. But because cosine of 5 pi over 6 was in the second quadrant, cosine is going to be negative in the second quadrant. When we plug in that reference angle, you need to include a negative out in front here. All right, the other thing we want to evaluate is that cosine of pi. So that's a quadrantal angle over here at pi. I like to visualize it as, if I have a unit circle going on, that ordered pair over there at pi is going to be the ordered pair -1, 0. And I remember that cosine is always our x value, and sine is always the y value for any of these ordered pairs for these angles. So we're looking at pi, which is all the way around here, and that's the ordered pair, the terminal point on the unit circle, -1, 0. And we're trying to evaluate cosine of pi, so that's going to equal -1. So I can go ahead and insert in -1 for cosine of pi. All right, the remaining business that we still need to do here is we can do a little bit more simplifying. Cosine of pi over 6 should be one of these values we know at this point. Very nice angle. So we can rewrite this as 1/2 multiplied by negative of cosine of pi over 6 should be square root of 3 over 2. And I'll go ahead and say -1, bring this -1 down. And then to complete this, we can do a little bit more as far as reducing down. This 1/2 on the outside, I'm going to go ahead and distribute that to clear out the big set of brackets. So we get negative square root of 3 over 4 minus 1/2. A little bit better answer would be if we had a common denominator and made this into a single fraction. So I'll do that to finish this up. I'll multiply by 2 over 2 with that second fraction to get a common denominator of 4. So negative square root of 3 over 4 minus 2 over 4. You can put these over this common denominator of 4 and say negative square root of 3 minus 2. And that's going to be the best solution we can get to. So as you're working through these, just take your time. Don't be in a hurry by any means. And I always like getting these reference angles instead of memorizing like 5 pi over 6, exactly what that's going to give. Hope this helps out as you're working on product to sum formulas. Good luck.